Okay, new booklet, new topic. It's chapter 10 of your textbook called Discrete Probability Distributions. Okay, so this is a new part of probability that you haven't learnt in your junior year. So we're going to start off with some terminology. Okay, so just some language of probability distributions. Let's firstly talk about what a random variable is. So that's a variable, can take on different values. That's what a variable means. It can take on different values depending on the outcome of a random process, such as an experiment. Random variables can either be categorical or numerical. Okay, so numerical, a number attached, and categorical meaning categories, which are usually words. Okay, so categorical values are names, objects, verbal descriptions, but numerical or quantitative, the values are numbers. There are two types of numerical, discrete and continuous. Okay, a discrete random variable is a numerical variable whose values can be listed. So if you're discrete, you can list the values. Okay, it's not continuous. In the domain, not every decimal is allowed. Some examples would be number of goals scored or amount of money in the bank, because money you can only put to the nearest cent. Okay, so it's not every decimal is allowed. So basically, for discrete random variables, not every decimal will be allowed. Okay. Continuous random variables are measured on a continuous scale, and normally they're measurements as well. In the domain, any decimal value is allowed. This means their sample space is infinite and can't be listed. So continuous random variables have an infinite sample space, whereas discrete has a finite sample space. Some examples of continuous random variables would be length, something you can measure to an infinite amount of decimal places, or temperature, which can also be measured to an infinite amount of decimal places. We focus on continuous random variables in year 12, but this topic's all about discrete random variables. Okay, let's do a question. Is it categorical, discrete numerical, or continuous numerical? So the height of a student. So height is something you measure, and you can have any decimal you like. The more accurate you go, you can just keep going. Okay, so I can say a student is this many meters. I could keep getting more decimal places. There's a continuous scale. The sample space is infinite, so it's continuous. The number of goals scored by a netball team. So it's a whole number, right? You can't say I scored 1.354 goals or whatever. It doesn't make sense. So therefore, it can be listed. So therefore, it's discrete. Okay. Now here we've got an inequality, which can be represented on a number line. So 4 and 8. Closed circle for 8. Open circle for 4. Anything in the middle here. Notice that this is any decimal allowed, okay, in this particular range. So there's actually an infinite number of values between 4 and inclusive 8. So therefore, this is continuous. Okay, the number of customers who arrive at a bank, obviously you can't have 1.427 customers or whatever. So therefore, the values can be listed as just the whole numbers. So therefore, that is discrete. And the birth country of a student, well, you could say Australia, you could say England, you could say whatever. But these are categories, they're words, so therefore this data is categorical. Okay, so that's a bit of a recap on the distinguishing between categorical, discrete, and continuous. Okay, and obviously this chapter we're going to be focusing on discrete random variables. Okay, page 2. For the random variable, we're going to use the capital letter. Usually it's X, okay? And the random variable basically covers all possible values. And then we use a little x for a particular value. Okay, so capital X is kind of like everything. Little x is a particular value. So find the set of all possible values. So that'll be find the set of X for each discrete random variable. So number of boys in a family of 4. So let's think about it. If you're thinking about how many boys can be in a family of 4, well, you can have no boys. 1, 2, 3, or you could have 4 boys, okay? So those are your different values that are allowed. The number of heads when tossing a coin 2 times. So And by the way, I'm doing the curly braces because I'm writing down a set of all possible allowed. So you could get a number of heads. You could have 0 heads, 1 head, or 2 heads if you toss a coin twice. The sum of two numbers when rolled on a pair of dice. So I'm assuming a standard 6-sided die. So the lowest would be if both of them showed a 1. If you sum, that's 2. And the highest would be if they both showed 6, which is 12. So basically, the sum will be anything from 2 all the way up to 12, okay? Just something to be aware of when we're defining our random variable, we're focusing on some particular aspect in a population from which samples can be drawn. So we focus in on a particular aspect. So here in part A, we focused on the number of boys. Here we focused on the number of heads. And here we focused on the sum. So you can see that there's a focus on what we're looking at for the particular experiment. So it's different to the sample space. For example, it's different to what we were doing in the previous chapter. For example, in the previous chapter, if I was tossing a coin 2 times, you would consider all options like head, 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 tail, tail, head, and tail, tail. Okay, you would consider like this to be a sample space. But here our sample space for our discrete random variable is looking at a particular feature, so the number of heads. So it could be 0, 1, or 2 there. Okay, another thing to note is that in the previous chapter, usually when we listed things, everything had an equal probability. So each of these has a quarter of a probability of happening. But when we do discrete random variables, we often have to assign a different probability to each particular value that it can take. So remember, capital X is everything. The little x's would be each individual. So if you want to write down that the little x's would be one at a time. Okay, 0, 1, 2, 3, or 4. All right, what I'd like you to do, very short exercise, complete 10.01, question 1 and 2. Shouldn't take you too long. See you in the next video.